Okay, so I had everybody put on here where inverse sine is allowed. And I know you probably knew that that was from here to here and it touches. But I'd like you to now write, instead of a picture, if I just asked you what is the range of inverse sine, how would you write it? You can't draw a picture. How do you write it without drawing a picture? Your answer might include pi over 2 in it. Because pi over 2 is right there. I think some of you understand what I'm talking about, and others are a little confused. Would you please compare this answer with the kid sitting next to you? Pontius, you can compare with people behind you. All right, can it touch pi over 2? Yes, it can. And if I was going to put pi over 2 and negative pi over 2, because that's what this is down here, the negative one has to be first, because whenever you put something in brackets or parentheses, the smaller number has to be first. So there you go. There is your range of inverse sine. Does that make sense to you? It's just saying the same thing as the picture did, except with brackets, because it can touch those spots. All right, how is inverse tangent different? It's very similar, but would you please write out what is the range of inverse tan? I'm gonna make it theta here, just because x can now be confused with a variable, of course. Well, if I'd have just asked you to draw it on here, most of you would have known it was here to here. But then how do you say that? Well, it's similar. It's just that it can't touch. So it's parentheses to parentheses. We had that one right. Okay, good. You on a phone? Not on a phone, are you? Oh, good. Okay, just looking down at your hands makes me nervous. All right, let's go do regular trig. Regular trig. Because this is in this unit because sometimes there's an inverse trig on the outside. But let's just do sine of pi over 2. You know that green could be a little hard to read from the back, so I'm going to rewrite it. Sine of pi over 2. Don't overthink this. There's only one place where pi over 2 is. And pi over 2 is an angle. So I already gave you the angle. I don't want an angle. All right, I'm going to pause for a second. So far, you should have known that pi over 2 is here, and that to do sine of that, normally we have like opposite and hypotenuse, but that doesn't work on this kind, because this is a quadrantal. And this one, you could label it as 0, 1, and then you'd know sine is y over r. How many of you had y written somewhere? Good, that's what you should have done. And then what is y? Well, it's 1. Over the radius, well, if you got to pick this point, you would have picked it at 1, right? This distance right there is 1. So it's 1 over 1, which is just 1. So your answer is 1. But then it gets weird, because then you do have to do the inverse cosine of that. You already did the first part. You don't have to redo it. You already know what sine of pi over 2 is. You already got that answer. I'm going to pause for a second while you figure out what that answer would be to this whole question now. Okay, so remember, when you've got one of these, they're saying, I need to figure out the angle, because that's what this is saying is It's not normal trig. Normal trig, they give you the angle. We have to figure out the angle. Well, what is the angle? Well, the angle where cosine is 1. Now, is this in the right spot for that? I know some of you probably thought it was. So let's talk about that. Here's our new question, because we figured out that sine of this was 1, so it's a new question now. It's just this question. So if I was going to start this question over again, would I be in the same spot? Well, I would be up here, because that's where inverse cosine's allowed, and it must be one of these 3 spots, because this is a quadrantal for sure. So my new question, you don't necessarily use that same spot. My new question is, where is cosine, which is really x over r, where is x 1? And it's at that spot where x is 1. That's your spot. Now, if you thought the answer was pi over 2, it's because you thought that the original drawing would just always work for both parts of the question, and it doesn't. The new question had cosine was equal to 1, so then x is 1, so then it had to be at this spot. So the answer is that spot, which is an angle, which is 0. Who had 0 on their paper? Excellent. Okay. All right, now here are your 4 hard questions. These are like the R3s of the test. And remember, you can get 1 wrong out of the 4, but and still get an A. But every one you get wrong after that is usually how this works. Usually you'll get 3/4 of the easy ones right, and then you get to the hard ones. And if you only get 1 right, you have like a B- or a C. If you get 2 right, now you're at a B. 3 right, you're at an A. So you can get 3 out of 4 of these and get an A. Before I do it, though, there's going to be one last review question. I just realized I haven't done any of these in a while. And we're going to make this be 1 over x. And then we're going to do cosine. One last practice like this before we start the 4 big ones. Okay, there's an x in there. That's weird. So he must be telling me 2 sides. And I'm doing inverse sine, so that's only allowed in certain places. Talk it through with your partner. Try to figure out what quadrant you must be in.
Yeah.
Inverse sine's only allowed over there, and there was no negative in it, so you should be in quadrant 1. All right, finish this one off. Remember, you've given 2 sides. You pretty much always need to find the 3rd side, and it'll have an x in it somehow, and usually the square root. Okay, sine is opposite over hypotenuse, and this side must be the square root of, and I know the hypotenuse is bigger, so I'm putting it first. And then this is not the longest side, so it must be minus. Who had x squared minus 1? Good. If you said 1 minus x squared, I forgive you, but in the test, you get that this is the longer one, and therefore you should take that be first and put it first, because otherwise you'll have a square root of a negative, and that'd be bad. The bigger one has to be first. All right. So then, cosine. Well, that's adjacent over hypotenuse. And adjacent's right here, and hypotenuse is right there. So it's square root of x squared minus 1. No, you can't simplify that. You might think you can, but you can't. I could tell you on a different day why you can't simplify this. But for right now, just trust me. And then that is your final answer. Okay. So here are the 4 big ones. And see if you guys can get 3 out of 4 of these right. Cosine of inverse sine of 3 over 4. Again, I've given you 2 sides. You'll always have to figure out the 3rd one. And then you do the question. Draw it in the right quadrant. Number 2. Tangent of inverse cosine of 1 over x. Number 3. Sine of arc cosine of 0. And last but not least, inverse cosine of sine of 4 pi over 3. I'm going to give you a spoiler on this last one. I thought there was no solution at first because the beginning part of the problem is in the dead zone. That does not mean that you can't have an answer, because the dead zone rules only apply to inverse trig. And on this one, that's not inverse trig. So when you're doing that, you can get an answer. Don't think, oh, there's no solution for number 4. I get it. I kind of thought that myself. But then, no. The beginning part of the problem is regular trig. There is an answer for that. And then there will be an answer for number 4 as a whole. All right. I'm going to give you about 10 minutes or so to see if you and your partner together can answer these 4 questions. So I'm going to get started. Number 1 here is right here. And inverse sine's only allowed in those two. And it's positive, so it can't be here. The positive one for that would be this. And then sine is opposite over hypotenuse. And then you might have thought 3, 4, 5. That wouldn't work because this third side can't be 5. It can't be the longest side. Square root of, and then you go this squared and this squared. So it would be 16 minus 9. So square root of 7. How many of you guys had a square root of 7 in your answer? Excellent. Then I need to now figure out cosine, which is adjacent over hypotenuse. So the final answer on this thing, you use that same drawing. Cosine is root 7 over 4. Okay, on to number 2. Inverse cosine of 1 over x. Well, inverse cosine's only allowed in these two quadrants. And the 1 over x thing, since it's positive, it must be here. And now it says cosine 1 over x. Adjacent and hypotenuse are the two sides we have. And then this must be square root of x squared. And since the x is the bigger of the two, I'm going to put it first. Minus 1. You could say squared, but it's just 1. And now I do tangent of that, which is TOA, opposite over adjacent, which is square root of x squared minus 1. And what's better, to put divided by 1 or to just not put divided by 1? Well, which more simplified? You don't really want to say divided by 1, because that's not simplified all the way. So yeah, it would have been all right to have that, but then you should simplify the final answer to square root of x squared minus 1. Now, I know some people think you could find this answer. It's not possible. You cannot simplify that to like x plus 1 or something. This is your final answer. Did anybody have that one right? Excellent. On to the next one. Number 3, we're going to do right here. And I've set it up where inverse cosine is only allowed on the top. And then it's of 0. That's obviously a little weird. I think it's always good to add the other side. Remember, this is arc, which means it's an inverse cosine question. So that is sides right there. So the sides being 0 is an indication I can't have a triangle. So then it must be a quadrantal. And I'm either going to be here, or here, or here. They're my 3 spots it could be. And cosine is x over r. Which one has an x of 0? That one does. Let's get its name here. This one's name is 0, 1, and its x is 0. So that's my spot. So this part here gave me sides, and the answer is an angle. The angle is pi over 2. So now this whole thing comes out to pi over 2 in there. So now my problem is sine of pi over 2. So I go back and I figure out, is pi over 2 in the same spot? Well, yeah, of course it is. So sine at that spot. Well, this spot is 0, 1, and the sine is the y. The y value there is 1. Who had 1 for your final answer? Yay! And then the last one. This one confused me because I was thinking 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, and then I was like, oh, trick question, it's in the dead zone. You can't do inverse trig there. And that's all true, except this isn't inverse trig. The start of the question is regular trig. And so sine is opposite over hypotenuse. So if this is really pi over 3's, this must have been a 60. This would be a 30. So I get my sides. 1, 2, square root of 3, most common mistake in circle trig, negatives. Whew, man, so much to know. And at the end, I wanted sine of that, which is opposite over hypotenuse. That over that. So this part here is negative root 3 over 2. Now I have a new problem. Look it. I'm not forced to use this spot. In fact, I can't use that spot. Why? Because now I'm using inverse cosine. Now I'm doing inverse cosine. This is a new, fresh question. I need a new drawing for it. Where is inverse cosine allowed? Only here to here. Can't be here, can't be here. So I clearly won't be in the third quadrant. And cosine's negative, so it can't be here, and it must be here. And cosine is adjacent. Oh, wait. Yeah, they gave me the adjacent side, negative root 3, and the hypotenuse is 2, and this must be a 1. And what's across from the 1 is a 30. So why isn't the answer 30? Because the answer of 30 would mean you're over here in this quadrant. That's not where we are. So that's a whole bunch of pi over 6's. 5 pi over 6 is your final answer. If you thought the answer was 30, look where 30 is. That's not where we are. It was pi over 6, and not just pi over 6, 5 pi over 6. Raise your hand if you had 5 pi over 6. I am impressed. You guys did better than I thought you were going to. That was a tough little set. If you got all 4 of those right, you would have for sure had an A on the test, unless you bombed all the easy ones, and it's pretty unlikely. If you get all the hard ones right, you would have bombed all the easy ones. Okay, so some of you are on track for an A tomorrow. So you have a required Schoology quiz. It counts as your homework. You might as well do it right now. And then there's the worksheet. That's a normal worksheet with a normal key. It's there just for you to pick up any last questions. Like, let's say you get a couple wrong in your Schoology quiz, and you're like, dang, I wish I could practice more like that. Go look at the worksheet with the key. You can do some practice there. Okay, so you got lots of resources with answers. And then tomorrow you can come in, and I really have a feeling this is going to be one of those bimodal results. I'm going to get 2 common scores. 95s, because you'll make 1 mistake out of 12 questions. Okay, there'll be a lot of 95s, and then there'll be a lot of like 60s. Don't let yourself be that 60. You can do this. This is doable. If you're stuck, come up and ask for help. And otherwise, you got to go through what is usually at least a 2-hour retake process. A little more study right now, or bomb it and have 2 hours later. Easy decision for me. I'd study more tonight. That's all I got for you for today.